Hello everyone, in this video I'm going to talk about the topic limits and continuity. Here are the example for continuity. Let the function fx, we have 2 to the power of x for the domain x greater than 0. The second function would be x squared plus 1 for the domain x less than equals to 0. So before we start the discussion, let's illustrate the situation in a number line. And we have the point 0. For the left hand side, x is less than equals to 0. So the function would be x squared plus 1. So equals to 0. We are going to use the function x squared plus 1. For the situation x greater than 0, which is the right hand side, the function would be 2 to the power of x. So now by referring to question A, find the limit when x approaching 0 for the function fx. So now we have limits when x approaching 0 from the left. Kindly refers to the diagram. For the left hand side, we have the function x squared plus 1. So after we substitute the 0, we will have answer approaching 1. Limits when x approaching 0 from the right, we have the function 2 to the power of x, and the answer will be 2 to the power of 0, which is equals to 1. So the value of y approaching 1 as well. So limits when x approaching 0 for the function fx, the answer is equals to 1. Because limits when x approaching 0 from the left for the function fx is equals to limits when x approaching 0 from the right for the function fx is the same. So, limit when x approaching 0 for the function fx, which is approaching 1, and the limit exists. So now I'm going to discuss the question B. Is the function f continuous at x equals to 0? Give your reason. So, in order to discuss whether it is a continuous or not, we have to refer to the definition, which is the condition for the continuity. Step number 1. f0. So by referring to the number line, f0 meaning that we are going to use the x squared plus 1. So we have 0 squared plus 1. So f0 will be equals to 1. Second condition, limit when x approaching 0 for the function fx exists or not. So for this situation, we are approaching 1 and the situation exists. Condition number 3, limits when x approaching 0 for the function fx, is it equals to f0? So by referring to the condition number 1, f0 is equals to 1. By referring to the condition 2, limit when x approaching 0 for the function fx is approaching 1. So for this case, limit when x approaching 0 for the function fx is equals to the f0. Since now we already satisfied the condition number 1, number 2, and number 3. So we can say that fx is continuous at x equals to 0. So here we are, and thanks for watching.